Okay, AP Calculus AB. This is an exam question, area and volume off the 2003 exam. I want to remind everyone out there who's paying any attention at all that this type of question has showed up on every single AP Calculus exam for the last 10 years. So there's no way that you're not going to see this, so you should be prepared. It says let R be the shaded region bounded by the graphs of y is equal to, and this should be square root x. So let me fix that really quick if you don't mind. It should be square root of x. And y is equal to e to the negative 3x power. That's y is equal to e to the negative 3x power. And the vertical line y is equal to 1. The first thing we're asked to do here is find the area of R. So the first thing that I did was this. I graphed this on my ti-nspire CAS calculator. So I have a ti-nspire. This is crucial because you can use this CAS. And I've done tons of videos on CAS calculators, and they are what you want to take to the SAT and to the AP exams. So what I did was I graphed this, and I found the intersection here, and this intersection point right here was the point 239. It's actually, and I'll show it to you, there's another way to do this, but I actually got a little bit more precise, but this is precise enough. I went to my calculator, I graphed in the line here that x is equal to 1. That's this line right here. X is equal to 1. That's this line right here. And then later we needed to have y is equal to 1, so I went ahead and graphed that in also. So this is what I have. So to do question number 1, remember that for part A of question number 1, it's only worth 2 points, and the 2 points are for the integrand and the answer. So this should be really easy. So for part A, this is what your calculus should look like, I think. If you have time, if you feel like you're ahead, then you can say a is equal to the definite integral a to b of f of x minus g of x dx. And just so you know, this is important that this is the top and this is the bottom function. And if you can see what I mean here, that when we're looking at this, this function right here, this square root function, is on top of this function the whole way through, isn't it? So what that translated into for me was the definite integral, and they said here x is equal to 1, so that's my upper bound. The lower bound is this intersection point, and when I did the intersection point on the calculator, I got 2.38734. The only reason that this is a little bit important is because it helps you from making rounding errors as you go further down the line. But if you use 0.239, because you got it from here, that will definitely work. And then what I'm going to do from here is just to find this area. I'm going to ask myself which one is on the top, and we can see here that x squared, that's this x squared right up here, x squared is this one right here, is at the top, so I'm going to take x squared, and the one at the bottom is this one right here, which is, can you even see that, sorry, which is e to the negative 3x power, can you see it? E to the negative 3x power here, so minus e to the negative 3x power. Remember to write, we're in terms of x, so remember to write dx, because we are in terms of x. From here, I'm just going to go straight to my calculator, and when I put this into my calculator just this way, I'm going to put this exact thing into the calculator, it's going to come out that the area, and I'm still going to use the approximation key, is approximately 0.442. So let's find our 2 points here. There's only 2 points for this section. 2 points. One, we have the integrand correctly. That's here. And the second is we have the correct answer. So 2 out of 2 points, which is what we are looking for. Section B is actually out of 3 points. And let's read section B. It says, find the volume of the solid generated when R is revolved around the horizontal line y is equal to 1. So this is what I did here. I'm like, here's y is equal to 1 right here. That's this line right here that we're looking at. And this thing is going to get revolved around this way, right? It's going to go around this way. So all I'm going to do is this. I'm going to start looking at this and say, look, the piece that's furthest away from here is the e to the negative 3x power, isn't it? So the radius, which is here, this thing is being spun, isn't it? The radius from here to here is 1 minus, right, is 1 minus, is 1 minus e to the negative 3x power squared. Remember, just take a look at this for a second. This is the x-axis here. This is the y-axis here. These are not axes here, right? This is not the third quadrant, right? I'm still in the first quadrant, but all these boundaries that they force me to put in makes it look a little bit weird. So that's what that little bit of confusion might be from. So I'm just going to start taking them and say, okay, I know that volume is equal to pi times the definite integral. I already know what the bottom number is. It's 2.387, right? 734, and it ends at 1 because they told us that, right? They told us that. And then of what? So remember that the formula I'm using is this. I'm using Rx squared minus Rx squared dx, where this is the outside radius, this is the inside radius. So I look at the outside radius, it's this one down here, isn't it? Right, this thing is being spun this way. So the outside radius is this one, so it's 1 minus that. Right, so we get 1 minus that. So we have 1 minus e to the negative 3x squared, that's the outside radius, minus the inside radius, which is again 1, minus, in this case, square root x squared. The whole thing is in terms of x, so I'm going to write dx. This is really important because you're going to get points for your integrand here, right? You got to have both radiuses here, and I'm looking at the scoring guide, and if they're saying if you don't put both radiuses, you're going to lose one of your points, and this is out of 3 points. I'm going to then drop this into the calculator and just put volume. Remember to use your approximation sign here. The volume is approximately equal to 0.453 pi, or your calculator might estimate what the value of pi is and do this multiplication, and you could get something like 1.423 or something like that, but then circle this answer, right? Checking, do I have all my points? Yes, I do. All right? What I should have been doing as I was going through this is checking these things off. Yes, I did this one. Yes, I did this one. And that leaves me with part C, which is actually really easy. It just sounds like hell, but it's not bad at all. It says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a rectangle whose height is 5 times the length of its base, blah, blah, blah. And you're like, what in the hell are you talking about? It's not bad. Imagine that you're looking down onto this region right here, and you're taking index cards and standing them up on their edge. So here's the edge of it, but it sticks up. I wish I was better doing it, but it sticks up like this. You know what I mean? And then another one. It sticks up like this. And pretty soon you have a solid sticking up from here, right? So the solid is going towards you, towards your face, and this is the base of it. So all we have to figure out then is, well, what would that look like? Well, that would look like a rectangle. Remember that the area of a rectangle is base times height. Well, we know that the base, right? We know what the base is. The base is, and right, we're going to look here and see which one is on top. And remember, the one that's on top is here, right? This one is on top, right? This one right here is on top. This is not the x-axis here. This is that line y is equal to 1, and we don't need to talk about that anymore. Here's the x-axis down here. So this line is on top, isn't it? And this curve's on top, and this one's on the bottom. So we're going to subtract them from one another and say that the base is equal to the square root of x minus e to the negative 3x power, right? The height is 5 times the base, so the height is 5 times the base, so we have 5 times square root of x minus e to the negative 3x power, don't we? And remember that the area of the thing is base times height, so if we multiply these two things together, we would get 5 times this times this. These two are the same, so it's 5 times square root of x minus e to the negative 3x power squared, right? Because we have two factors of this. So we have that squared. And now we're actually almost done. We're just going to put this into integrand form and say we know that the volume is equal to the indefinite integral from 0.238734 to 1, right, of 5 times square root x minus e to the negative 3x squared, right? That's this squared is this squared. This is all in terms of x, so dx. So this is all of that justification that they were looking for, and this is worth 3 points. This part right here is worth 2 of the 3 points. So I've had lots of students who are really smart, and they can come up with the answer. The answer is worth only 1 of 3 points. So you need to get 3 of 3 points. So finally, for the last point that you can receive, you put the volume, and the volume is about 1.554. They didn't give us units on this problem, and therefore we didn't have to put units cubed or anything. So we can just leave it like this, and I've put a little box around my answer so that the reader can find it easily, and go on to the next problem knowing that you've done a really good job on this one. All right? Look, I hope this is really helpful. If you have any questions or comments, please let me know. I'm going to try to get as many of these things done in the future as possible. If you haven't already subscribed, please subscribe. Thanks for the support. Appreciate it.